Hello everyone. In this video we're going to talk about RAID 5 and RAID 6. Now previously I did do a video about RAID 0, 1, 5, and 10 a few years ago, but I never covered RAID 6. But to understand RAID 6 you need to understand RAID 5. So that's what we're going to talk about. Now RAID stands for Redundant Array of Independent or Inexpensive Disks. In a RAID setup, the data is copied or spread on multiple disks, so that in the event of a disk failure, no data would be lost, because that data is spread on other disks. So let's talk about RAID 5. Now, in order to use RAID 5, you need to have 3 or more disks. RAID 5 is a common setup that is used, especially in companies, and that's because it's fast and it can store a large amount of data. Now, in a RAID 5 setup, the data is not duplicated, but it's striped or spread across multiple disks. And in addition to the data, there is another very important piece of information that is being evenly spread across all the disks. And that information is called parity. And parity is used to rebuild the data in the event of a disk failure. Now, in a RAID 5 setup, if one disk were to fail, you would not lose any data, because RAID 5 is designed to handle a single disk failure. So all you would have to do is replace the failed disk with a new one, and then RAID 5 would use the parity information from the other disks to rebuild the data on the new hard drive. However, if 2 disks were to fail at the same time in a RAID 5 setup, then all the data would be lost, because RAID 5 is not designed to handle 2 disk failures at the same time. It can only handle 1 disk failure at a time. So in our example here, this setup is using 3 disks. But since it's using RAID 5, the equivalent size of 2 of these disks are actually used to store data. And this is because it takes the equivalent of 1 entire disk to store parity. So if these disks were 1 terabyte each, 3 of them combined would equal 3 terabytes. But only 2 terabytes would be used for actual storage, because 1 terabyte would be used to store parity. And that brings us to RAID 6. Now, in order to use RAID 6, you need to have 4 or more disks. Now, RAID 6 is just like RAID 5, where the data is striped across all the disks, and parity is also spread on all the disks. But the difference is, in RAID 6, parity is spread twice on all the disks. And the reason for this double parity is so that it can handle 2 disk failures at the same time. So in a RAID 6, if 2 disks were to fail at the same time, which is pretty rare, no data would be lost. And all you would have to do is replace the failed disks, and then RAID 6 would use the double parity from the other disks to rebuild the data on the new drives. So in our example here, RAID 6 is using 4 drives. So that would mean that the equivalent of 2 of these drives would be used for actual data storage. And the equivalent of 2 disks would be used to store the double parity. So again, if these disks were 1 terabyte each, that would be equal to 4 terabytes, but only 2 terabytes would be used to store data, and the other 2 terabytes would be used to store the double parity. And it's also important to note that the read performance from RAID 5 and RAID 6 are about the same. But as far as writing data, this is where RAID 6 suffers greatly, because since RAID 6 has to write 2 independent parity blocks instead of 1, the write performance will be a lot slower when compared to RAID 5. So that's the difference between RAID 5 and RAID 6. Thank you for watching, and I'll see you in the next video.